Hello, everybody. Welcome to Raw and Real. Glad to have you here. I know everybody's still getting their audio hooked up and signed in to Zoom in the first place. So if you're here already, if you want to go heat up your coffee or brew a cup of tea, we're going to start promptly in 2 minutes. We will start at 10:02 at the top of the hour. You are at Raw and Real. Let me share some slides right here so you can know where you are. Maybe it's more so I can know where I am. Here at Raw and Real, our short, sweet product demo, how Honeycomb uses Honeycomb, and today specifically, how we instrument tracing and how we help our users instrument tracing. So if you're, we're glad to have you here today. Again, we'll start promptly at 10:02. If you need live captions, of course, you can open up the captions bar at the bottom of your screen in Zoom, but also if you choose to follow along, you can use this link. Let me paste it for you here in the chat as well, so it's a little bit easier. Thank you, Kimberly, for joining us today to do captions. Again, you're at Raw and Real, and this is episode 7, the tracing you deserve so you can observe. We'll get started officially in a couple of minutes. There we go. Let's see. Again, welcome everybody to Raw and Real. We're glad to have you here today. I'm just triple checking all of my buttons to make sure everything is in place. We are recording this episode today. 1 second. Something feels off, so I'm just going to check it real fast, everybody. Nope. There we go. I can see that we're recording. So a reminder that we are recording for those of you who are joining us today. This episode will be available after the event. I think with this new update, I've lost some of my buttons. Paul, I'm so glad that you're here with us today. Let's show our faces. Everybody, I'm Kelly. Welcome. Some of you may or may not know our instrumentation engineer, Paul Osman, who's joining us today. How are you today?
I'm doing great, thanks. How are you doing?
I'm okay. I'm okay. Now that I know all the buttons are in place, I can, yes, everything's just fine. So I'm really glad you're going to join us today. Paul, could you give the folks at home just a little bit of information about who you are in terms of developing software and why you might care about instrumentation?
Yeah, certainly. So, yeah, thanks everybody for coming. I'm really happy to be here and happy we're giving this demo today. So as Kelly mentioned, I worked on our instrumentation team. We're the team who make it easy as possible to get data into Honeycomb. So any SDKs or libraries or integrations that help you get data in. Before joining Honeycomb, I spent most of my career working in some form of SRE or ops. I've led ops teams. I've been part of ops teams. I've managed incident response, et cetera. So I come from a background of using a lot of tools like Honeycomb, and now I help build a tool like Honeycomb. Yeah, so lots of experience implementing this stuff and now actually helping others implement it.
Okay. It looks like we have a good number of people signed in right now. I want to remind everyone listening along at home today, if you have any questions, ask at any time. If you put them in the Q&A box in your screen, we can see them just a little bit easier. We love hearing, hey, there you go. We love hearing from you in chat as well. So please chat it up. Let us know you can hear and see us. Let us know you can hear and see the presentation. Paul, I think we had a question for everybody out there. What's helpful to you? Do you want to know how many people in the room are already practicing tracing?
Yeah, that would be
Okay.
great.
Okay. How many folks are already, where are you in tracing? Do you do it every day? You're brand new to it, or you don't know what it is? Please let us know. Thank you so much in the chat. Please let us know where you are with tracing, because I know it definitely has gotten a bad rap for being difficult to set up, and that's why we're here, is to talk about how easy it is for you to have it, because it's table stakes these days. Okay. New to it, started last week. Fantastic. Tracing. Okay, perfect. Okay, I think this is going to be really helpful for people who are just getting started with Honeycomb. Yep, this is great. I think it's also going to be really good for people who are getting teammates onboarded. Paul, you were talking a little bit about your experience. Can you share a little bit of that pain that you're talking about with tracing and how difficult it has been to get set up? Like, what's so painful about it?
Yeah, for sure. So I think there's a couple things that come to mind for me. One is the idea that tracing is two things, really. There's tracing within an application, which is completely useful. So it gets sort of shoeboxed into like the world of just microservices and just tracing along distributed applications. But you can add tracing to one application, and you can do things like custom instrumentation, so you can create spans around critical parts of your application, et cetera. And then there's the other part, which is the distributed tracing. And that's, of course, where you have multiple services that are calling each other, and you want to actually, tie together those service calls in a tracing, visualization in a tool like Honeycomb. There's an impression that in order to get value out of the second, you have to instrument all your services, and that's another thing that I found is not actually true. So, there are companies out there with 4 or 5 services. There are companies with hundreds of services. If you have hundreds of services, you're not going to want to have to instrument every single one of those services before you start getting value. Just start with one. Start with one that's most critical to you and your team and your customers. And that could be really dependent on your business. Maybe you have a service that's been a part of a lot of outages and you want to know more about it. Add tracing to that service. As you discover dependencies that service calls out to, then add tracing to those services. And what I want to show today is that you can minimize that implementation difficulty by using tools that provide auto instrumentation for applications. You're muted.
Story of my life today. Thank you so much for going through that. I think we should just get right to it and show these folks how it's done.
Absolutely. So let me just share my screen. And what I'm going to share here is I've got two very, very simple contrived example services, but hopefully they're representative at least of the type of services that you'd experience, that you'd encounter in the wild in your companies. The first one is a really simple Ruby service. It's using the web framework Sinatra. And all it's doing is stubbing out, a user store. So all of the data statically coded, but in a real world, of course, this would be hitting a database like Dynamo or MySQL or something like that. And it's got two endpoints. One just checks for an email address, and then the other verifies a password. So it'll check the bcrypt, password for a user account, and then return a 401 if it's incorrect, or return the user object if it's correct. So really nothing fancy there, obvious example service. The other service I have is a Python service. I chose to do this in 2 languages just so you can see that it's relatively similar in different languages. This service has one endpoint, and it accepts a post request, and it accepts a username and password as a JSON document, and then attempts to verify that password by calling out to the Ruby service. So that's what I really wanted to do, is I wanted to create one service calling another to demonstrate, real world scenarios where you have service dependencies. So let's run these quickly just to make sure everything is working. Let's see, I'm going to run my Python app. I'm going to run these locally on my laptop. And I've run the Ruby service. Okay, so I can hit the Ruby service directly. And here's that verify password endpoint. If I wrong password, I get a 401. If I type in the right password, I get a 200. And then let's call the Python service. So this is the one that has a dependency. Here we go. So I'm calling, just the only endpoint. I'm sending a post request with a JSON document, and that works. And as we can see, actually, just by looking at the standard output logs, I'm getting a 200 here, and it's generating a 200 over here. So it's clear that I'm calling one service, it's calling another service, so we have a service dependency. But at the moment, we have no idea what the heck is happening. We can see that they're successful, that's great, but if this was actually in a production environment and users were hitting it with real traffic, I wouldn't know what the hell was going on. So what I want to do is first add, just Honeycomb instrumentation. So let's start with the Ruby library, or the Ruby service. I'm going to go to the documentation for our Ruby Beeline. Beelines, for anybody who's unfamiliar, these are our auto instrumentation and tracing libraries. Really useful if you're using any popular web frameworks like Rails or Sinatra, et cetera. In Ruby, we have them for other languages as well, as I'll show. And what I'm going to do here is just kind of copy paste code examples. So I got to import the Beeline and then just configure it. And what I'm going to be showing is this just gets us, data into Honeycomb. So let's say Honeycomb Beeline is the gem name. There is my configuration. I'm also going to give it a service name so that on the Honeycomb backend, I can see spans that are, or events that are generated from this service will get the service name attached to it. I've got my credentials set up as environment variables. So let's just do this. All right, so my Beeline is configured for the Ruby service. The last thing I need to do is I mentioned I'm using Sinatra. So I just need to tell the Beeline that I'm using Sinatra, and I do that by using middleware. So I just copy and paste this line.
This is all just right in our docs. You're literally just taking, this is a bridge.
This is just copy and pasting from our docs. Hopefully it's this easy for most people. This is what we really want to aim for, is we want it just to be a copy paste, search for your framework, grab the line of code you need and put it in there. And as you can see, I've now got 1, 2, 3, 4, 5, 6, 7 lines of code. It's all boilerplate. There's nothing really special going on here. So that's the Ruby service. Let's actually just restart it quickly and make sure that I didn't screw anything up. All right, it's at least starting. So now I'm going to go over and do the same thing in our Python service. So go to the Beeline for Python documentation page. And same thing, let's just grab that initialization code. There we go. So I'm importing the Beeline. Same as before, I'm using environment variables. So let's see. There we go. If I could type, there we go. And then similarly, I'm going to give it a service name so that I can differentiate events on the back end. And there we go. Now, just like before with the Ruby service, I was using Sinatra. This Python service is using a framework called Flask. So I'm going to go down here and look for this line here, which is just, again, a little bit of middleware that wraps my Flask application. And that should be it. Oh yeah, one more piece is because I'm using a library to make outgoing HTTP calls, I also want to import our requests wrapper. So what this does is it actually just wraps the Python requests library so that when I'm making outbound calls, they're instrumented the same as everything else. With me so far?
Yes, this is making sense to me.
Perfect. Let's try it out. And I'm seeing already that I got a key error here. Honeycomb write key. Okay, so let's see. Wasn't finding the environment variable. And same thing with the data set. It's not a live demo if everything goes right. Okay, oh, and then I forgot to import the Honeycomb middleware. There we go. That's all. Cool. Okay, so let's actually give this a shot. I'm going to do the same thing I did before. I've now got both services at least using our Beelines. So what I should expect to see if I make a bunch of these calls is some information on our backend. I am going to make a few calls that error out. And then actually, let's see. There we go.
Just make it fail, Paul. Just make it fail.
It's not interesting if everything's going right. All right, so here's my Honeycomb account. And I can see now that I've actually got these traces coming through. I can see total requests. I can see a latency distribution as a heat map. This is looking good. So I know that the data is getting to my account. So let's take a look at some of these. So I see a bunch of traces here. And I can click on here. And this is just looking at an individual trace. But what we see is we've got the authentication service calling out to the user service. And despite the fact that they're two different code bases, added a few lines of code. And the main takeaway here is that I didn't have to go in and like do a bunch of custom stuff. If you do that once to your code base, you're going to stitch them together, and I'm getting traces assembled on Honeycomb's backend here. So if I wanted to, I could also go in and add, do some querying using our query builder, etc. Let's see. Perfect. And then, of course, I could do any kind of slicing and dicing I want to, and I can look at the traces from this view as well. So that's the basic use case. That's it. That's when you're using Beelines across the board. The whole takeaway there is that you just add the library. That's really all you have to do is add and initialize the library. You don't have to go and hunt down every part of your code that's doing certain kinds of operations. So hopefully that eases some of the concerns with adding tracing. The next thing I want to show is what happens if you're mixing and matching different instrumentation libraries. So in this example, I was using Honeycomb Beelines with Honeycomb Beelines. I'm sure a lot of people are aware of OpenTelemetry. OpenTelemetry is a huge community effort to create a standard and implementations around tracing and metrics and other kind of telemetry data. And Honeycomb are really big fans of OpenTelemetry. So we want people to be free to experiment with OpenTelemetry, start to look at adopting OpenTelemetry if it's right for them. And one of the things that can be hard is when you're working on tracing is taking like one part of your system and changing it, right? Like if you have these traces flowing through your system, it's a big ask to say like, okay, well, now take this other one and instrument it with something else, because you run the risk of breaking your traces then. And then when you're debugging, you lose track of like the critical customer journeys in your system. So what we've done to make it easier for people to try out OpenTelemetry or migrate to OpenTelemetry is we've added what we call trace header interoperability. And so let me demo that really quickly.
Okay, yes, please.
What I'm going to do is I'm going to take the Python application that I had that's instrumented using the Beeline, and we're just actually going to replace it with another one that is instrumented using the OpenTelemetry Flask auto instrumentation. So I'm not going to go through the actual exercise of instrumenting it. I already have one here, but just to show you the difference, it's really not that different. It's literally just boilerplate that's changing from one example to the other. Same thing, I set up a Honeycomb exporter, I create a trace provider, and then I auto instrument my app by providing a wrapper. The rest is the same. So let's go in and run that one. Okay, that's now running. Now, what's going to happen if I run this, though, is out of the box, the trace header format is different. And so if I try to run this, the Python application is going to send trace context in a header format called W3C trace context, which is used by OpenTelemetry. And our Beeline has to be told then to look for that. Oh, pardon me. So what we've done is we've added these hooks that allow you to kind of mix and match trace header formats. So if I look at the documentation again, interoperability with OpenTelemetry, I see that I can, in my configure block for my, my Beeline, I can set up this HTTP tracer hook. And that allows me to either use a canned parser in this case, which I will be for the W3C trace context header, or I can do like custom stuff here. So I can choose to actually just parse the trace header depending on the origin of the request, or I could try multiple trace header formats if you have an environment where you have like maybe Nginx is in there sending B3 headers, which is another format. You have some OpenTelemetry in there. I can do whatever I want here, but this is just the simplest example. So let me add this to my Ruby app. Here we go. And I've got to import the codec. Okay, so now I've got two apps. One of them instrumented using a Beeline and the other instrumented using OpenTelemetry. And let's just add a bunch of requests. I can see that that's coming back okay. Let's go back to Honeycomb. And I'm seeing, perfect. I'm seeing traces. And so you can see they look a little different just because what's auto instrumented by OpenTelemetry is a little different sometimes than what's auto instrumented from our Beelines. But I have a service here using OpenTelemetry, calling out to a service using a Beeline. And because we use the trace header parser hook, which does interoperability between different trace header formats, everything just stitches together on the back end and looks great. And that's all I have to show.
That's it. That's very, very straightforward. So, okay, so what I see here is a lift to help instrument tracing from either Beelines or OTel, and it looks like they're interoperable, which I didn't expect. That's going to help a lot of people out there. I also really appreciate the value that you raise of, I can imagine that making this big change, especially if you're so frustrated about being able to understand system behavior across all of these distributed services, being able to make a change that you just take a small chunk and put something in there to give you visibility, you're definitely taking this mountain and breaking it down into a manageable piece. And that takes tracing from difficult to table stakes to understanding user behavior. Okay.
Yeah, absolutely. Yeah, start small and start where you think the value is going to be highest, and then work outwards from there. That's always my suggestion when taking on some endeavor like adding instrumentation.
Okay. That sounds fantastic. I'll remind everyone in the room right now. Hey, I've got one question in the question box. I'm opening it right now. Excuse me. Oh goodness, Michael's asking if we're working on a tech stack that supports both styles of auto instrumentation, Beeline and OTel. Which do you suggest we use?
That's a great question, and one that comes up a lot, actually. Honestly, not to dodge, but I don't have a straightforward answer. What I'm going to suggest is use whatever is most important to you. If portability and using an open standard is important to you, I would definitely suggest OpenTelemetry. We are committed to making OpenTelemetry a really first-class experience for Honeycomb users. And so that's going to continue to be, somewhere where we focus effort, is making sure that that experience is really good. On the other hand, OpenTelemetry is not GA yet. So that is a concern for a lot of people, depending on how much of an early adopter you want to be. And you may find as a result that some of the Beelines are, more feature filled. So really, I would suggest, if you're willing to take a little bit of a risk and that, lack of vendor lock-in is important to you, then definitely I would recommend, giving OpenTelemetry a shot. If you would rather wait, then, as you've seen, our Beelines are compatible with OpenTelemetry, so you can always add it in later once it's made generally available, depending on your risk threshold. Just know that things may change in the next little while. They are looking to get to GA pretty quickly, though, so we're getting closer and closer.
How many folks, and here's a good question. Let's see, what can I do to trace what can I do to trace manage services I rely on? I use Timescale Cloud, Postgres as a service. I see the directions for both self-hosted, but this feels in between. This here in the chat, what do you have for that, Paul?
Yeah, for sure. So using anything like RDS, managed service, you don't have the ability to go in and instrument your code, the code there. So, obviously your options are a little bit more limited. One thing that we suggest is just do it in the application. So when you're calling out to Postgres, for instance, you're about to make a query, instrument your Postgres library. And a lot of our Beelines will actually do auto instrumentation of a lot of SQL libraries, popular SQL libraries. So that's one option, and that at least gives you the application's perspective on what's going on. But obviously, it's not going to give you everything. If you want to look at table locks, or if you want to look at row lock contention, things like that. We have another tool though called Honeytail. Let me bring it up here.
Yeah, we're doing good on time.
Cool.
If you want to show,
so,
sure.
Honeytail is in our documentation in the same section. And what it will do is it'll actually parse a lot of popular, open source application log formats and turn those log entries into events that you can look at in Honeycomb. And so what you may want to do is, like I said, both. Why not both? Instrument your application so that you wrap all of your queries to Postgres or to whatever RDS service you're using or whatever. And then also run Honeytail and send data directly from your Postgres logs or whatever to a separate data set so that you can look at those as well. You can definitely mix and match there, but yeah, you're hitting on something good, which is that your options are kind of limited when you can't touch the code.
I'm just throwing a link to the doc section that you're bringing up right here in the chat. Folks, I'll send out as many of these links as possible in an email following this, but I just want to make sure if you're in the zone, if you're in the context of this today, I want to make sure that you can have them. Excuse me. Again, if you have any more questions, we'll take a few more right here. But what I'd really like to ask is what I see today, Paul, is getting started small. You've just taken 2 services and gotten data into a system so that you can understand how you can trace along the path of the behavior. Is there a limit on how many services tracing can support?
No, not at all. So from Honeycomb's perspective, spans in a trace are just events that happen to contain certain metadata that allows Honeycomb to stitch that that event into a trace. So I've seen traces, with 4,000 or more spans in them. It doesn't really matter to Honeycomb where those spans are coming from. So you can have hundreds of services all emitting spans as part of a trace, and you should have no problem being able to visualize that.
Thank you. Let's see. Can you tell us about exporting Honeycomb telemetry context through OTel headers instead of importing OTel headers into Honeycomb?
That's a great question.
I love these questions.
So that we actually don't support. So our Beelines cannot, oh no, sorry, I shouldn't say that. Yes, we can do that. So our Beelines actually have what's called a parser hook, which I showed, and then there's a propagation hook. And so let me just show the part, obviously because of time, I won't be able to demo this, but I can show where that propagation hook looks. Here we go. This is where the example code lives in our documentation. So similar to how I added a parser hook to our Ruby app to accept incoming W3C trace context headers, what this would do is if I added a propagation hook, and actually I can just do this here, it's all the same libraries. So right alongside my parser hook, I can add a propagation hook. What this will do is it'll take any outbound HTTP requests from my Ruby application, which in this case, I don't have any, but if I then added something where I'm calling out to yet another service, it would include the W3C trace header in that service so that if it was an OTel service, just by default, it would be able to pick that up and use it to construct traces.
Thank you. Thank you for that. Great. Thank you for that answer. Really appreciate it. Let's see. I know we don't have time to demo that as well, but there's a couple of other places that you could possibly see that if you're interested. We do a weekly live demo. It's at the top of our website. I'll send this out in the email too, but I'm going to throw a link right here. It's really an overall demo, but if you have a specific question, they'll try to show it to you. So reach out that way for sure if you want to see something specific. Or Liz and Shelby also do office hours. That's our developer advocate team of Liz Fong-Jones and Shelby Spees. They do dedicated office hours. So if you want to talk through some of this specifically, we're at KubeCon this week talking about OpenTelemetry with a lot of people right now. And we're really excited to see more people get the tracing that they need right there, not having to switch tools, but right there in front of them so they can really understand user behavior. Paul, just kind of as an outgoing, I don't see any last questions. So just kind of as an outgoing thought, do you have any thoughts for folks in the room about the value that tracing can bring? I mean, I could talk about, definitely saving time, understanding if your systems are slower, you can improve them, or if a user is having an issue that's not showing up in your monitoring tools, you can trace along that for sure. But as an engineer, that pain, how is life better with tracing?
Yeah, for sure. So really quickly, I just added a GitHub repo to answer also the previous question that has examples of using both tracing parser and propagation hooks. But to answer your question, Kelly, like tracing allows you to do something really important, which is to zoom out and take a look at like what part of a user journey might be causing pain. That's how I see it, at least. So like there are some great examples of problems that are really easy to detect once you've got tracing implemented. One of them would be like when you add microservice dependencies to a system, it's really easy to do things like a famous one is N+1 service calls. So let's say you have like a service, like a user service, and it returns a list of users. And then for each user, you need to look up some specific piece of information like an avatar or a username or something like that. it's very common to end up actually, just by accident, calling out to that service for each user. And you can look at that in a trace and see that, oh, there's all these RPCs being made from service A to service B. And it just becomes instantly apparent. Whereas, if you're depending on other forms of telemetry like logs or metrics, you may wonder why, your user service gets so much more traffic than the service that's calling it. And it's because of this N+1 problem. So there's all sorts of customer pain issues that can be identified, performance problems. The other one that's really popular is, of course, just looking to see, based on the duration, which is the length of the span in the visualization, what's slow in your system, what's taking longer than you expected to. Those are a lot of specific situations that can come to mind.
Thank you. I can see how that's really helpful when you're on call trying to solve an issue. And I can also see how it tightens the feedback loop so that people who are building software can know how their code affects production sooner and might affect users based on their specific situations.
Yeah.
So let's see. We actually have a couple more questions. Paul, I'm going to keep going for the folks who can stay. If you have a few more minutes, you good?
Yeah,
Great.
absolutely.
Do you have any example Node.js apps that have
Mhm.
the Beeline SDK set up, specifically apps with async, promises?
That is a great question. Something we do have that I'll point you to is here. Let me pull up two things. Actually, I'm going to pull up the GitHub repo for the Node Beeline.
Okay.
Let's see. That has, yeah, pretty much. So our Node Beeline has the same sort of doc structure as the Python and the Ruby one that I showed. So hopefully this should be able to at least give you, enough to get started. If you need more than that, we also have this examples repo. And this isn't the most maintained thing we have, but for things like examples of just using an app, it does have some pretty good stuff. I'm not so we have a node tracing web app, for instance, that uses our Beeline. Unfortunately, I'm not sure if it has async setup. The best place to get an example of that, honestly, would be if you're part of our Pollinator Slack channel. Just pipe into the SDK-Node.js Slack channel and ask somebody hey, you got a quick, GitHub gist or a code snippet of setting up a Beeline with an app that uses async promises. A community a member might get back to you, or somebody who works at Honeycomb will get back to you and just show you a quick example.
Thank you so much for that. We have one more here in the chat as well. If you had to implement telemetry on a small app that has none, what would you chase first? Chasing with some basic error
That's a
success,
great
span
question.
logging. Thanks. Go ahead.
Yeah, I was going to say, so depends on what you mean by small app. I've been in situations where you have a monolith, for instance, a monolithic code base, and it calls out to a bunch of microservices. In that case, I'd start with the monolith because you're going to get the outbound calls. So, it depends on if this app lives alone, if it exists as part of a microservices architecture. I always think go to the thing that the customers hit the most, or the thing that, is the center, so to speak, of your user journey. But let me see, if you had one service with only 2 external dependencies, great. So what I would start with then is just add a Beeline or an OpenTelemetry auto instrumentation library to that service. And you're going to get a lot of data for free. When you go to Honeycomb, you're going to get things like, duration for every request handler. You're going to get, the HTTP method used, if it's assuming it's an HTTP service. You're going to get the path. You're going to get the status code. And that'll give you off the bat, a level of visibility into your error rate, into the durations, into, where requests are coming from. And then you can start to do custom instrumentation. So once you've got the Beeline in there, then you find out, what's most important in your app. What are the parts of the application that are doing things that are more complicated? And then add custom spans around those things where you can add fields to each span and just see what context matters to you. But start with just the auto instrumentation. Honestly, you're going to get a ton of data out of that. We always say auto instrumentation can kind of get you there, and then you need to tell your library what's most important to your app because only you know that part. But just started by dropping a Beeline or OpenTelemetry auto instrumentation library and we'll get you pretty far to start.
I really appreciate that. I don't see any more questions at this time. Paul, thank you so very much. I really appreciate it. I also appreciate everyone who's participated, who's listened to today, who asked questions and then gave us answers to our questions. If you have more that we didn't get to today, you can reach out at team@honeycomb.io. There's a link in the chat. If you liked this episode or if you didn't like this episode, I want to hear it. I have a short survey. Help our team make things that make things better for you. I need some more coffee. Try that again sometime. But I really appreciate everybody coming. And Paul, thank you so much for sharing with us today. I'm glad to have you here.
No problem. Thanks everybody for coming.
Have a great week.
Take care all.